Good morning, everybody. We're taking a look at a few things about chemical equations. I hope you're all doing well. So this is halfway through the week, and we're going to take a look. These are the vocab terms I'm hoping you're starting to pick up while you're doing these equations, but if you're not, let's figure them out now. First off is the word reactants. That, of course, is the left side of the arrow. That's what's reacting, believe it or not. And the product side of the arrow is the right side of the arrow. The subscript is like the 2 in H2O, and it goes below. That's why we use the word sub, the line itself. Coefficient is the line in front. That's the numbers you've been adding as you've been balancing equations. They're correctly called coefficients. Phase notation, sometimes, and I've left this out for now, we might jump into it next week, but that's when you know what phase of matter your reactants and products are in. You just see a little parentheses, and it would be G for gas, S for solid, and AQ for aqueous or dissolved in water, or L for liquid, although that's pretty rare. Balanced, of course, we know what that means. And sometimes I actually don't use this term much, but some teachers would say, they would say, the reactants yield the products. I don't use that term much, but just in case you hear it in the future. Here's an equation to balance. I've said this many times, but in case this is the first video or you've missed it or you're really struggling, maybe this will help you. Always take the largest compounds, right? So up here we've got this compound looks like a beast, and it's a lot. So I always take those largest ones and I avoid them when I'm balancing. Okay. Instead, I'm going to start with the smaller compounds and start from there. So let's take a look at what that looks like for us. I've got lithium carbonate over here. There's 2 lithiums, and I've got 3 lithiums over here. I've seen this maneuver many times where there's a 3 charge and a -2 charge, and I just know I have to swap those 3s and 2s. So I put a 3 here, that gives me 6 lithiums, and I put a 2 here, and that gives me 2 lithiums. That also, don't forget to bounce that too, so now I've got 6 lithiums here. I also have 2 PO4s. Don't forget to use any polyatomic should be seen as a unit when you're balancing. So now I've got 2 phosphates. I have those 2 phosphates right here. Remember, that's a good sign when it already lines up ahead of time. That usually means you're doing something right. And now I've got 3 bariums, and I only have 1 on this side, so I put a 3 in front of it. Now that gives me 3 carbonates as well, and I already have those 3 carbonates here, so woohoo, we got her. Next slide, please, sir. Oh, look at that. I have the numbers there, and they come up really confusing. Like, one thing I want to point out is the notation at the end here. That's those phase notations. That means that this barium carbonate is a solid. Everything else with the AQ means aqueous, or means that it's dissolved in aqua, or water, of course, for you English speakers out there. We've got 5 classifications of equations. I'm going to run through these very quickly. If you want to come back to it and review it, feel free. There's also tons of videos online and tons of pictures, but real fast. Here are my expectations. I forgot about this slide. That just this for this week, I expected you recognize what kind of reaction it is. I expect you can balance those reactions. And next week, so not this week, we're going to start predicting products of reactions. And now let's talk about the types of equations, the classifications of equations. This will really help next week when we start predicting how our equations are going to react when I don't give you the products or the reactants. So you can look forward to that. So real quick, we've got single displacement reactions. That's when a singular element reacts with a compound, and that element takes the place of a part of that compound to create a new compound, and then the element that it traded out for becomes by itself. This is way easier to show just by showing you an example. So here I've got magnesium reacting with hydrochloric acid. This is a fun reaction, by the way. It creates a lot of hydrogen gas, and you can see it explode when we light it. I think we did it earlier this year. If not, bug me next year during the study hall or something. But real quick here, we've got magnesium and it's just going to trade places with the hydrogen. And that's a single displacement. Other textbooks will call this a single replacement. Both mean the same thing, so it's not worth complaining or arguing about. With bigger reactions, especially when my big face gets in the way, it can be a little bit more difficult to notify it. But here we've got copper sulfate and a singular element. That's always the clue, is if there's a singular element. The aluminum takes the place of the copper, and then we've got copper by itself. That's like the reaction we did earlier this year when we took the copper and added it to the, we took the copper sulfate, the blue liquid, and we added iron to it, and the iron took the place of the copper, and the copper came out of the reaction, and it made it look like the iron was transforming into copper, if you remember that lab. I don't know. I hope you remember labs. I also know we usually just remember the colors from the labs. I'm guilty of that as well. Do not worry. The lab I remember the most from high school is the one where we made paper airplanes in physics class. All right. Double displacement is the next one, also called double replacement. Not worth arguing about unless you're a college professor. So, in this case, instead of a single replacement, we've got two things trading places. What? Notice that it's two compounds. That's always a clue. If you've got two compounds reacting, making two other compounds, that's always double displacement. I always think of this as the most difficult, so it's double difficult or double displacement. But in this case, you can tell the metal sodium and the metal hydrogen. I realize hydrogen is not a metal, but it is going to act like a metal in this reaction. So the sodium and the hydrogen are going to trade places, and now instead of sodium combining with OH, it is now combining with the Cl, and we have sodium chloride, and hydrogen is going to react with the water. This is a very interesting reaction because it makes salt water. Just kidding, it's not interesting. All right, and this is what it looks like, the more complex equation. Once again, we have copper sulfate. It reacts with the aluminum hydroxide, and the, correctly, sorry, I misspoke, copper 2 sulfate. The copper is going to trade places with the hydroxide. I'm sorry, I misspoke. The copper is going to trade places with the aluminum. It's always the metals or the cations that trade places. And so therefore, I've got copper now with hydroxide and aluminum with sulfate. So I'd have copper 2 hydroxide and aluminum sulfate. This next one is synthesis. It's when you take two things and you put them together to make one thing. Yep. Synthesis means to build. Photosynthesis, you're building sugar from light. Synthesis, building two things, one thing. Pretty easy, right? I'm not going to go over. Decomposition. This is like synthesis, but the opposite. So we've got one compound and it makes two things. Sometimes people get confused because if you look in this second example here, it is decomposing even though it still has a compound over here, right? Two different elements, but it did break off part of it. So it is decomposing. It's getting smaller. So here you can see an example of that. We've got potassium chlorate becoming potassium chloride and oxygen. It's decomposing. It's getting smaller. The last one here is combustion. This is a fun one. I really wish I could go over tons of examples of this in class. We do have a lot of fun ways to show combustion. So here you see, it's always the same. This is always the same. No matter what's combusting, it's always going to react with oxygen. You know fire needs oxygen. If you don't, now you know. That's why you can stifle fire, not with your hand, that would burn you, but by covering it with a blanket. And then it creates CO2 and water. Of course, that's the CO2, right? That is currently causing global warming. At least that's the theory. So it is true. Global warming is a thing. But anyways, the first part here is the only thing that changes. That is called the hydrocarbon. A hydrocarbon, get this, has carbon and hydrogen in it. It's a hydrocarbon, and you can see what it looks like down here. Should we do some examples? Let's do some examples. So real fast, we're going to run through these examples. I'm not going to spend too much time on it, but what kind of reaction is this? Well, it's got a hydrocarbon in it. I just pointed with my finger, but you can't see that. It's right here, and it's reacting with oxygen, making CO2 and water. That is going to be number 5, combustion. This one is 2. Singular elements becoming 1. So if we're taking 2 smaller things and building them and putting them together, that's always synthesis. This is going to be, I've got a singular element and a compound. That's always my trick. Ooh, I spat on the screen. That's always my clue that this is going to be single displacement or replacement. Here we've got a large thing becoming 2 smaller things. That's decomposition. Here we've got 2 compounds. Anytime I see 2 compounds, I know that it's going to be double displacement because it's doubly difficult, although it's really not. Now we've got a singular element, so I know it's single displacement. And now I've got a hydrocarbon, hydrogen and carbon. And of course, this is going to be combustion. I'm trying to stay under the 15-minute limit that YouTube imposes on me. This is double displacement. Now I've got 2 elements coming together, synthesis. Here we've got a compound, and it's 1 large thing becoming 2 smaller things. It's breaking down. It's decomposing. Here's where we're going next week, and I am not going to jump into it right now. But this is the, oh man, it's a bad time for a yawn. But here's where we're going next week. I am going to give you part of an equation, and you're going to predict where it comes from and how it forms and what it makes. Do not worry, I will help you out with that. We will figure it out together. I hope you guys are having a good week, a good restful week. And if I can help with anything, message me any time of day. Do not feel bad. I've had some people apologize to me when they message me at like 3 a.m. or something, because that's when you guys are doing your work. Don't feel bad. I turn my phone off if I don't want to respond to it. I just don't turn on notifications from when I'm sleeping. So don't feel bad. Don't apologize for that. I am happy to answer questions, and maybe I can't sleep and I got something to do at 2 a.m. when I wake up or something. Who knows? But yeah, I hope you guys are doing well. Once again, if there's anything I can help with, please send me a message. I need to know what's out there. I need to know what you're struggling with, and it's a lot harder for me to know what you're struggling with when I can't see your faces of confusion in class. And some of you have really good confused faces, by the way, and it makes it super easy on my part. It takes no social skills to read some of your confused faces, which is good because I lack in that. All right, I hope you guys are having a great time, and I will hopefully see you sometime. Bye.